Hello, in this video we're going to be talking about AP Chemistry's topic 3.3, solids, liquids, and gases. Now you may think that this is a very simple topic, and it's not an overly complex topic, except that we're not talking about solids, liquids, and gases as a fifth grader would understand, and we're talking about it as a AP Chemistry student would understand it. So let's just go into what makes a solid, a liquid, and a gas. It all comes down to attractions between the particles that make up the substance. Are the particles strongly attracted to each other? Are they less strongly attracted to each other? Or are they very, very, very weakly attracted to each other? And that attraction determines everything about solids, liquids, and gases. So first, we'll just start off with solids. With solids, you can have crystalline solids, where the structure is very organized and the particles that make up the substance are in a very regular repeating pattern. If you think about ionic compounds, the ions are in a regular repeating pattern. If you think about ice, the particles are in a regular repeating crystalline pattern. If you think about sugar, you have a regular crystalline repeating pattern of the particles. But there are some solids that don't have a crystalline pattern, and those are called amorphous. Amorphous solids do not have a regular structure. This usually happens in compounds that have very large molecules that are free to rotate and move around. For instance, if you think about large hydrocarbons, carbons all bonded together into very, very long chains, those long chains are free to move and bend and wrap around one another. Think about spaghetti. That's kind of how these hydrocarbons wrap around one another. So plastics, which are hydrocarbons, and waxes, which are hydrocarbons, tend to form amorphous solids because the hydrocarbons, the carbon compounds, can wrap around one another and they don't form a nice regular repeating pattern between the molecules. With solids, you can only have vibrational movement. There's three types of movements that we'll talk about. Vibrational, which is where the particles just move back and forth in place, but they're not able to move past one another. If the particles can move past one another, that's called translational movement. Translational movement. And in solids, you have no translational movement because the particles are not able to move past one another. Again, if you think about an ionic compound, this is real easy to figure out. If these ions are locked into place, they can't move past one another. So no translational movement, but they can vibrate due to the thermal energy that they have. And then another type of movement is rotational energy. And when you have a crystalline solid, the particles are not able to rotate. They're stuck in place. All they can do is vibrate. So all thermal energy in solids is vibrational energy. Again, we've talked about ionic solids, and ionic solids are made out of ions that are attracted to one another. There's molecular solids, where you have two nonmetals bonded to each other, making molecules, and those molecules are attracted by intermolecular forces. So the solid is held together by intermolecular forces, which are dipole-dipole forces, dispersion forces, and hydrogen bonding. Ionic compounds are held by Coulombic forces between ions. And then last but not least, we have metallic solids. Actually, it's not last. Metallic solids, of course, are attractions between the atoms of a metal. And in that, you have a sea of electrons that are holding all the atoms together by electrons jumping from valence shell to valence shell of all the different metal atoms. And then the other type we've talked about is covalent network. In a covalent network solid, there's covalent bonds between every atom. And this happens in carbon. So you can have diamond or graphite. Those are covalent network solids. Silicon dioxide, sand, has covalent network in it, glass. And then also asbestos is a covalent network solid, which is also a silica compound. Okay, liquids. Liquids are much more similar to solids than they are to gases in the sense that the particles are very close together. So solids and liquids still have very close contact between the particles. However, the particles can move past one another. So you can still have vibrational energy within the molecules, but now you can have translational movement between the molecules. They can move past one another. They're strongly attracted to each other, so it's hard to do this, but the molecules can move past one another, and that's why we say liquids can flow. Liquids flow because the particles are able to translate past one another. They can move past one another. And the nature of the movement depends on what types of forces are between the particles. So if you have an ionic compound, how the ions move past one another depends on whether positive and positive are attracting each other, or negative and negative are near each other. And I don't mean attracting, near each other. Molecular compounds, again, it just depends on how they attract each other. But the big thing that determines the nature of the forces between the particles are the intermolecular forces, the charge of the ions, or the temperature. This is going to determine how the liquid moves. Solids and liquids have very similar densities because the molecules are so strongly attracted to one another, and both solids and liquids are called condensed states of matter. These are condensed states. As opposed to gases, gases are not condensed. The particles are very far away from each other. They're spread out from one another. So with gases, the particles are in constant motion, and they have translational motion, they have rotational motion, they have all kinds of motion. But the gases, the particles are independent for the most part. They don't attract each other with strong forces. And we've talked about how with gases, an ideal gas, there would be no attraction between the particles. With real gases, there's slight attractions between the particles, but the particles are so far apart from one another that attraction is very negligible. So we have very large distances between the particles of a gas, and how the gas behaves depends on the pressure of the gas, the volume of the gas, and the temperature of the gas. So under high pressures, particles will be closer together and they will attract each other a little more strongly. That's going to affect how the gas behaves. At low temperatures, the particles are going to be able to attract each other a little bit more. That's going to affect how the gas behaves. If you cool the temperature down enough, the particles attract each other and they become a liquid. Same thing with volume. If you decrease the volume of a gas, eventually you can push the particles so close together they can become a liquid. But if we expand the gas, then that puts particles farther apart and the particles are more independent of one another. There is minimal attraction between the particles of a gas. And because of this, there is no definite volume to a gas. The particles are independent to move wherever they want, and there's no definite shape to a gas. Because, again, the particles are not attracting each other, so they can move independently of one another. So that's just a quick discussion of solids, liquids, and gases. If you have any questions about this topic, please let me know.